Hello guys, welcome to Ramta Solutions and welcome to your grade 11 probability. Video 1 of our grade 11 probability is looking at dependent and independent events. So, sometimes knowing something about an event can tell you something about another event or other events. And I can tell you something about another event or other event. Okay, and this is where we have to look at dependent and independent events. So, now, if outcome of one event influences outcome of the other event, you must know that the two events that you're looking at are dependent. I repeat, if outcome of one event influences the outcome of another event, you must know that the two events are dependent. In other words, what we are saying is this: if you knowing the probability of one event affects the probability of another event, you must know that the two events are okay. Now, if outcome of one event does not affect the outcome of the other event, you must know the two events that you're looking at are independent. Okay, I repeat, if knowing outcome of one event does not affect the outcome of the other event, you must know that the two events are independent. Okay, so in other words, with independent events, knowing outcome of one event does not affect the probability of another event. Okay, so independent events, I must say this, if events are independent, they will have this formula. Let me use a black color. If events are independent, they will obey this formula. Okay, if events are independent, you must know this. Probability of, I must use a bigger font size. Probability of event A and B will be equal to probability of event A times probability of event. Okay. Remember guys, if events are independent, probability of event A and B will be equal to probability of event A times probability of event B. Okay, so when you test dependence and independence of events, you must use this formula. We are going to explore it later. Let's get into the mathematics of it. So normally, we like saying, if with independent events, we like saying probability of A if we know B, okay? Probability of A if we know B will basically be equal to the number of outcomes of A and B over what? Over the sample space of, or over the number of outcomes, not the sample space, but over the number of outcomes of event B. Okay. Now, another thing that you need to know, you know by now that probability of A, right? You know that probability of A, right? You know that probability of A is number of outcomes of A over the sample space, all right? Over the sample space. So now, what we are also saying is that, okay, we are basically saying probability of A is basically probability of A if we know B, all right? It's basically probability of A if we know B. Okay, if we know B. Okay, if we know B. Okay, so this is what we know. Now, let us now try to remind ourselves. Remember we said? Okay, remember we said we are now going to prove this just now. Remember we said probability of A and B is equal to probability of A times probability of B, right? You guys remember that, right? Perfect. Now, let's remind ourselves. Okay, so we're going to leave probability of A as it is, or maybe let's change it. Probability of A will be number of outcomes of A and B all over sample space. What is probability of A? What we're doing here is we want to return you to this fact here. Okay, we want to return you to this fact here. Okay, now what is probability of A? Let's leave it as it is. What is probability of B? Probability of B, it will be number of outcomes of event B over a number of outcomes, over the sample space, right? So we are looking for probability of A. So we can therefore say this is number of outcomes of A and B over the sample space. If you divide by probability of N over B, it will be multiplied by sample space over number of outcomes of event B, right? Which is probability of A. Now, as you can see, these guys will cancel. What are you left with? You are left with probability of A and B equals number of outcomes of event B, which is equal to probability of A. Now, what did we call this? We said this was probability of A if we know B. Therefore, probability of A if we know B is equal to probability of A. Okay, it is equal to the probability of A. Okay, it is equal to the probability of A. Happy? Perfect. Now, let's try examples. So now we're going to try examples. Remember, guys, to prove that events are independent, you need to say probability of A is equal to probability of A and B is equal to probability of A times probability of B. So now, let's say we have, let me try this. Let's say we have, as an example, we have 5, how many examples am I going to do? I think I'm going to do 2. So let me call this one here example 1. So we have 5 red balls and let's say 5 blue balls and 5 blue balls. So we remove record. Okay, we remove a record and return the ball. Okay, so the first question is, what is the probability of first ball being red? First ball is red, right? Probability that the first ball is red. Number 2, what is the probability that the second ball is blue? Probability that the second ball is blue. What is the probability that first ball is red and the second is blue? Right? First ball is red and the second is blue. Okay, and then 4, we will say are the 2 events independent? Are the 2 events independent? Let me just say that. Are the 2 independent? All right? Are the 2 independent? Okay. So now let's answer the questions now. We will try 2 examples, remember? So now let's see. The first one, I should have said 1.1. Okay, 1.1, 1.2, 1.3, 1.4. So the first one, remember in our sample space, we have 5 red balls and 5 blue balls. So the first one, probability that the first ball is red. Guys, I want to show you something before I answer this question. I want to show you something. Let's say we have, in our solution, I'm going to do a long thing here. I want you to imagine this. We have 5 blue balls. It doesn't matter which is which, but I'm just gonna say maybe they are slightly different. So we're gonna say we have blue 1, 2, 3, 4, 5 and red 1, 2, 3, 4, 5. Right? What I'm gonna do here, it's gonna be a lengthy exercise, but at the end, it'll answer our questions nicely. Okay, so let's see. You can have the first ball being blue, meaning blue 1, blue 1. The second one is blue 1. And then you can have blue 1, blue 2, blue 1, blue 3, blue 1, blue 4, blue 1, blue 5, and then blue 1, red 1, blue 1, red 2, blue 1, red 3, blue 1, red 4, blue 1, red 5. Right? Blue 1, red 5. Now we're going to try blue 2, blue 1, blue 2, blue 2, blue 2, blue 2, blue 3, blue 2, blue, okay, blue 2, whatever. So it's fine. As you can see, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we're going to have B. So we're going to have B3, B1 just like that. And then we're going to have B4. We're going to have B4, B5 in a row of B. We're going to have B5, B1. And then we're going to have red 1, blue 1, and so on. We're going to have red 2, blue 1, red 3, blue 1, red 4, red 4, blue blue 1, and then red 5, and then red 5, blue 1. So as you can see, this is 10, right? So what is this? This is 10. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 10 times 10. So it's basically 100, isn't it? It's basically 100. So now, this question is now asking you, what is the probability? Remember, it's 100. So guys, everything here, I'm just changing the first letter. It's going to follow this order. The second ball will follow this order. But the first ball, if I started with B3, it's going to be B3 just like that. Okay, perfect. So now, the probability that the first ball is red. Okay, the probability that the first ball is red. Now, the probability that the first ball is red, as you can see, we don't see it in this half. We see it in this half. What is this? This is 50 over. What is this? This is 50, right? This is 50 because it's 1, 2, 3, 4, 5. And we said it's 10 rows, right? So it'll be 50 over 100. So this probability will be half, right? But now let's use a formula to answer this question. It will be probability of the first ball being red. First is red is obviously for the first ball, we have 5 red balls to choose from. Let me just say number of red over sample space. So what do we have? We have 5 red balls to choose from. And how many balls do we have in total? We have 10. And what is this? 5 over 10 is half. If you recall, we said here we have 50 over 100, which is half. Happy? Perfect. Now, number 2, probability that the second ball the second ball is blue, right? Probability that the second ball is blue is equal to second is blue. Let me say that second is blue over sample space, right? Probability that the second ball is blue. Look at this. What do we have here? We have 1, 2, 3, 4, 5, isn't it? So if you can look at it, this portion here is 5 times 10. What is that? It's 50, isn't it? It's 50, isn't it? Probability that the second ball is blue, it's still 50. Second ball, we're looking at this. Even here, it's second ball is 50 because there are 5 balls. So it'll be 5 times 10, it's 50. All right? Now, we are expecting 50 over 100, which is a half, isn't it? 50 over 100 is a half. So let's see now mathematically, what do we get? So for the second time we choose, how many blue balls are there? There are 5 blue balls. How many balls do we have in total? we have 10 balls in total, and this equals half. Happy? This equals half. Now, number 3, we're saying probability that first is red, and second is blue, will be first red and second blue over sample space. Now we're gonna try this with this diagram that we drew. Remember, we didn't have time to write all of them. So let's see. First ball is red, right? First ball is red. So let's see, when the first ball is red, where do we start seeing it? We start seeing it where? In this half. Remember guys, this half is one that says B2, B3, and then R1, B4, and then R1, B5, and then it's going to be R2, B2, blah, blah, just like that. All right? First ball is, look at this. First ball is red, second ball is blue. How many do we have here? It's 5, 10, 15, 20, 25. Isn't it? We have 25 over, how many balls do we have here in total? Over 100. Right? So 25 over 100 will be a quarter. Right? 25 over 100 will be a quarter. So we are expecting mathematically to get a quarter. Now let's try this. With this, what we are going to say is, first time we get a red, we have 1 over 2. The second time, for us to get a blue, we have 1 over 2. So what is this? This is 1 over 4. Can you see that? The first time to get a red, we had half. The second time to get a blue, we also had a half. Therefore, the probability that the first ball is red and the second is blue is 1 over 4. Happy? Perfect. Now, let's go now. I believe we must try the fourth question, 1.4. 1.4. So 1.4 says, are the events independent? All right, so we must ask ourselves, what is the probability of red times probability of, if you recall, we said for reds will be half, for blue it will be half. So what is this? It is a quarter. What is this? This is equal to probability that you're getting red first and blue after. Therefore, the events are independent. Let me just write this, red first and blue after. Since probability of R times probability of B is equal to probability of R and B, we can therefore say the events are independent. Alright? We can say the events are independent. Remember guys, for events to be independent, what did we say? We said probability of event A and B must be equal to probability of event A times probability of event B. Happy? So this is it. This is it, guys. Okay, this is it. Happy? Perfect. Now, we're going to try another example. It's going to be slightly different to this one here. It's going to be slightly different to this one here. So, we're going to say, now we're going to say, example 2, we're going to say, again, we have 5 blue balls and 5 red balls. And 5 red balls. So what do we do here? We pick a ball, record it, and not return it to the set. And not return it to the set. And not the return. So now 2.1, it's going to be, what is the probability that first ball is blue? First ball is, let's say red. Let's start with red. Probability that the first ball is red. Second question, what is the probability that the second ball is blue? Probability that the second ball is blue. Third question, what is the probability that first ball is red and second is blue? Then 2.4, are the events independent? Are the events independent? So we don't have to draw that long list I drew. By the way, guys, that list, okay, that list was for me to show you that the reason you are doing mathematics is to simplify your workings. Nobody has time to be drawing all these things. As you can see, I was tired to be writing B1, B2 until whatever. I was tired to write it. So I'm trying to show you here that with maths, this tedious exercise can be simplified. And you simplified it by saying, look at this. This is how you're able to simplify it. Do you see that? Now, okay, now let's answer the question. Our solution will be, I'm going to start here. 2.1, what is the probability that the first ball is red? Now, probability that the first ball is red. For this one, you guys need to be careful. You guys need to be careful, like very, 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 very careful. Okay, you guys need to be very, very careful. Okay, so what are we saying? So what we are saying is this. I want to show you this perhaps before we proceed. Let me show you this. When you look at this, if you were to look at let's say, for example, probability of getting red and then red first and red second will be, first time, you have 5 reds over 10. Second time, what do you have? You have 4 reds over 9 because you picked a ball and never returned it. So now your number of reds have increased. So what do you have here? You have 20 over 90. So we can call it 2 over 9. All right? I'm just showing you now. Now let's go to probability of getting a red and then a blue. Probability of getting a red and then a blue. First thing first, you have 5 reds over 10. And then how many blues do you have? You only removed a red, so you still have 5 blues over, however, the total is now 9. What is this? This is 25 over 90, isn't it? 25 over 90. So perhaps let's call this 5 over 18. Right? It's 5 over 18. Now, let's try. You pick blue first, and then you pick after. So it's still 5 over 10. And then if you pick blue first and you pick blue the second time, you now have 4 blues over 9 in total. So what was this? I think we said it was 2 over 9. We said it was 2 over 9. Now what is the probability of saying you pick blue first and then you pick red after? It will be obviously 5 over 10. And you now have 5 reds because the first ball you picked was blue, but the total number of balls you chose from were 9. This is 5 over 18. Now let's answer the question. What is the probability of choosing, hear me out, what is the probability of choosing red first? It's easy. With this one, you don't even have to waste your time. It's easy. Probability of choosing red first, it's easy to say it's half, right? It's easy to say it's half. But if you like, you can say if you like, you can say it's probability of red plus probability of red and blue. What is this? I believe red was 2 over 9, and then probability of red and blue was 5 over 18. Right? It was 5 over 18. So what is this? What is it, guys? It's 9 over 18. So it's half, isn't it? It's half. You didn't even have to do it like this. You could have just said red first. It's simply 5 over 10, which is half. But you can also do it in this way. Or let me show you here. Or you can say it's 5 over 10, which is half, isn't it? It's okay, right? Now, now 2.2. It wasn't 1, eh? It was 2.2. 2.2. Let me check what he said there. This is 2.1. So 2.2, the question was saying, what is the probability that the second ball is blue? Probability that the second ball is blue probability that the second ball is blue, what will it be? We can say it's probability of red, blue, plus probability of blue, blue, right? What is the probability of red, blue? Red, blue, we found it to be 5/18. 5/18. What is the probability of blue, blue? Blue, I think will be, blue will be 2/9. All right, so blue is 2/9. So of course you guys have calculators. Your calculator returns half. Now with this one, it is not that easy to just say, okay, it's 5/10. It's not that. This is because you have two situations. What if the first ball that was removed was red? You get it? If the first ball that was removed was red, you cannot say it's easy to do. So it's better to do it this way. Okay? It's better to do it this way. All right. Now 2.3, probability that first is red. All right? First is red and second is, by the way, this is basically saying to you probability of red and blue. Okay? So what is it? With this one, we're going to say probability of red first and blue after. Can we get it? Yes, we can get it. Red first and blue after. Here is it. It's 5/18. All right? It's 5/18. This is straightforward. 5/18. So this one is number of outcomes of whatever over sample space, whatever. So we're not even going to waste our time. This one, remember how you do it. You're supposed to do it like here. You're supposed to do it like here. Okay. You're supposed to do it like here. Okay. So we're not going to waste our time. We're going to say it simply 5/18. But let me just write it here. So I'm going to say it is 5/10 times. Again, it was 5/10 and 5/9. Yeah, 5/10 and 5/9. Remember, you removed red first. The number of blues are still 5. However, this means because you removed one number, the total will now be 9. So we said this was, I think you said it was 5/18. You said it was 5/18. All right? The last question said we must show if the events are independent. So let's go. 2.4. 2.4, we will say, what is probability of first red first times probability of blue second. All right, what is it? It will be, let's go, red first. What did we get? We got half. Half, and then for blue, did we also get half? Yes, we got half. So what is this? This is a quarter. Now, this is not equal to 5/18, isn't it? This is not equal to 5/18, right? What do I mean by that? I am saying probability of, in other words, this is not equal to probability of first red and second, right? Therefore, these are not independent. Okay, these are not independent. If you like, you can say these are dependent. So these two events are not independent. Okay, guys. So this is how you look at your dependent and independent events. So with that being said, ours ends here. And remember, you would like to get in touch with us, visit our website, www.aramtasolutions.co.za. And at the top on our website, you will see all these icons. If you click on any of them, you will be directed to these sites. Or if you are on social media, you'll be directed to these social media apps. And of course, you are watching on YouTube. please like, subscribe, and share with friends. And if you would like to get a tutor, please use these two icons and we will try to assist you as best as we can. With that being said, ours ends here, and bye-bye.